the goal now is to talk about Python magic methods. So Python magic methods are methods, so functions defined within the body of a class that help make object-oriented programming possible and very easy in Python. So let's just look a little bit at what they do. So they come with, how do they arise first? When defining them, they come with double underscores before and after. So you've seen an example with init, for instance. And the fact is that you don't have to use them, you don't have to call them afterwards using that name. So new shortcuts are defined for them that make calling them very easy and very useful. So some of them with those shortcuts enable a form of operator overloading. So for instance, they allow you to do things like object1 plus object2. So they do this by defining a new method that will be called add. So underscore underscore add will be the double underscored method name, and plus will be the shortcut. And plus in this case overloads the operator plus. The fact about magic methods is that you don't need all of them for sure. You can do without most of them. You can do with all of them without all of them, I think. But in general, magic methods, you should see them as answering the question, wouldn't it be nice if this was possible? And the answer is, it's most likely possible, and it's most likely designed so that you implement it with magic methods. The fact that you give very specific names to those magic methods, that you don't have a choice for the magic methods, is a very good thing because it allows Python to figure out quite a bit of what you're trying to do and do a lot of it for you. In general, an excellent resource for magic methods is the website that is linked in the PDFs. So I encourage you to look at that. So what are some examples of magic methods? Well, the first one I want to talk about is initialization. So you create here a new object of type myClass by passing some arguments to it. And so for instance, this might be, okay, I'm lying a little bit, but this might be this call. You're creating a string here by passing an int as argument. Another example is whenever you type print and then an object, something has to be printed. So somehow Python needs to know what to print at that moment. Even if you have quite complicated objects, Python will print something. Another example is requesting the length of some container, so some list. A list always has this function defined on it, but it's not defined on other objects. So for instance, if you call the length of a dictionary, that won't be defined. You can also request, with this mechanism, the square brackets, you can also request some objects inside my object using a key. Okay, so for instance, this works for dicts if you pass some key, some other object, and for lists if you pass an integer here. You can also compare different objects or objects of the same type or even different types. You can compare them with some binary operators. You can also use those binary operators in a different way, where my object, so the first object and the second have different types. So if you have, for instance, this list, and then you can multiply it by 10, and you will have a list with 10 times the entry 5. You can also slice objects using this colon. So this is also enabled by magic methods. You can call the directory of an object, so all the attributes that are defined for your object, and this will also use a magic method. You can check containment, check that an object is in a list, for instance, and this will use a function called contains, a magic method called contains that we'll see in a second. You can call functions that you have defined on new arguments. Again, this is enabled thanks to magic methods. And finally, you can use this with construction. So this context that is called with, and again, this is enabled by magic methods. So each time I said this is enabled by magic methods, for some of the most built-in types, it might not actually be done that way. But it's very helpful to think that it is done that way, and because it will provide for you a coherent way of thinking about those magic methods. So at this stage, I want to encourage you to pause the video and actually go see the videos with the examples, and then come back later to this one where you will see all of the different types of magic methods in a more structured fashion. But the advice I have to give you is that you should first look at some examples to get a feel for what they can actually allow you to do. So I want to give you now some examples of magic methods, some more examples, and kind of categorize all the different uses for them. So you should really have an easier time understanding this material if you have looked carefully at the examples before. So the first use case is construction and destruction of objects. So this enables, for instance, calling str with just the round brackets and creating a new empty string. So this creates a new object in memory, and eventually you save it to a string. This is the general syntax. You call my class with some arguments and some keyword arguments, some positional and some keyword arguments. So in this case, the magic methods are new, init, and del. And del, of course, deletes an object from memory. And so it's only relevant if you have very memory-intensive operations, and I won't assume you have in this course, although this is debatable. The init object is definitely very relevant to you or to anyone who does object-oriented programming in Python. And the new is only important in some very specific use cases. So whenever you need to be very careful when you free up memory. So I won't talk about new very much because this only occurs in very rare cases. Okay, the next magic methods that you're likely to use, and you're very likely to use them being mathematicians, are comparison operators. So this enables to compare different objects, for instance, this string and that one. So the magic methods there are CMP, that stands for compare, equal, not equal, less than, greater than, lesser equal, or greater or equal. And of course, they have shortcuts associated. So this one has this shortcut, this one has that shortcut, this one has that shortcut, that one, and finally this one. Now, if you think about it, this is 6 different magic methods that I told you about. So it's kind of stupid if you have to define a new method in order to be able to use this operator, a new method in order to use that operator, a new method in order to use this one, and so on. Especially because all of those are extremely related, right? I mean, you know that something is equal if it's not equal. At least in most cases, they should be related. Python offers you the possibility of doing whatever you want with those operators. So you could make it distinct from the usual use cases, but in most cases, you want the natural behavior. So in this case, you can use CMP. And CMP, if you define it, Python automatically defines all the other ones to do the right thing. And how it works is that you return a negative number, 0, or a positive number, depending on which way the comparison goes. So I think less than is minus, 0 is equality, and plus is greater than. And from there, Python figures out all the rest. So that's one example of an advantage you have in standardizing those names, because Python knows that if you define a CMP function with double underscores like this, it means that you are intent to define an equal, a not equal, a less than, etc. Okay, so that was for comparison. But there are other numeric binary operators and functions, and those don't need to be between the same types. So as I said before, you can use a string and an integer, you can add different strings together, etc., etc. So how do you do this? Well, you define the relevant methods, which might be add, mul, floor div, which has a shortcut like this, div, which has a shortcut like that, and true div, mod, which has a shortcut with a %, and so on, pow, which has a shortcut with this. We've seen the exponential, L shift, that's the shortcut, right shift, that's the shortcut, and so on and so on. So whenever you define one of those methods, you are effectively defining a new shortcut for yourself that you can use with your objects. Now, this was for binary operators one way. So you define it for, let's say, add, and you define it with self and others, and later on this is understood if you do self plus other in the code, right? So this is the function definition, and this is usage. So those are in different parts of the code. So what Python does is figure out whether objects of the type of self have an add method defined, and if they do, then they use that method. But if they don't, then they will look for other, so the class definition of the type of other, and they will look if this has a method called radd for reverse addition defined. And if it does, then it will use that with swapping the two arguments. Okay, so other will become self and self will become other. All right, so this is reflected binary operators, and you can just use the binary operator names and change binary magic method names and add R to have the relevant name. So you have R-mel also, for instance. Okay, so numeric augmented assignments enables things like this. So plus equal exclamation mark. So if you have a string plus equal another string, then what will that do? Well, it will perform an addition and then put that, assign that to the first object. Except that it will be smarter than that, because it will generally just append the second part, and this is more memory efficient. So again, there's this little recipe. The magic method names translate to the same name with I added. So that's for augmented assignment. And I put numeric because there's no reason to expect this to just be used for numbers. It can be used for any object. So you could have some vehicle where you do plus equal a person. So this is just adding a person to a vehicle. That would work as well. There's also unary operators. So this enables to do specific things when you see a plus or a minus, etc. And this is defined with pos, neg, abs, which is the absolute value, invert, round floor, cell, and trunk. Okay, so you have to look at the documentation in those cases, but I don't expect you to actually need that. There's type conversions as well that enables int of the object, eggs of the object, etc. And of course, this is just defined with this or that. Okay, and it's not defined in all cases. There's just some limited number of cases where that is allowed. There's also class representations. So this enables to do string of my object, rep of my object, hash of my object, and dir of my object with the corresponding magic methods, of course. So this is important because this is what's called first when you do print my object. Okay, so this is another example of how magic methods are useful. You have an object and you ask to print it. What Python will do is it will look if string is defined, or underscore underscore string underscore underscore. And if it is, it will use it and expects it to return a string, and then it tries to print that. If it's not defined, then it will look for the next best thing, which is rep. And rep is some computer readable definition of what the object is. So if you have here a print, you can return anything you want if you want. If you have str, you can return anything you want. You can return some explanation for a human of what that object is. Well, if you have rep, you have to return something that a computer can use. Containers. So containers are, for instance, dicts or lists, etc., tuples, and this enables to call length or a specific key, to assign some value to a specific part of the container, to check for containment, etc. So each of those examples given matches up to one of the specific magic methods there. So we've seen this in the examples, or we'll see more. Attribute access. So if you have math, which is a module is an object, and what you're doing here is accessing the attribute sin, and you do that with this dot. So this is obtained thanks to getAtr. If you want, and it's the same for myObject.anAttribute. If you want to assign, then you are using setAttr. And there is a subtle difference between the two, but I won't really get there. It has to do with what to do if the key actually does not exist. So what if you do myObject.not an attribute, but some crazy stuff? Okay, so some crazy stuff that does not exist as an attribute of my object. So that can only be decided at runtime, and you can have a different behavior than just returning a key error if you want. callable objects. So functions are just objects like any other. That means you can call them. So you can. That means you can. That means that you can hook up into the calling mechanism of objects that are callable and modify the behavior. So if you have my object, open bracket, some arguments, and maybe this should be swapped, then this actually calls the function call that will be defined for the class giving the type of my object. So if you want, you can have an object that's callable but does something very specific every time it's called. So this, for instance, could be used to define some caching mechanism for functions. Okay, so if you think about it, so this is one use case for call. If you think about it, a caching mechanism that we've seen before for decorators, when we were looking at decorators, a caching mechanism saves some data associated to a given function. So it's a perfect use case for object-oriented programming, because really here you have some data that's really, really tied to a function. So this means you should define a new class that has as data attributes both the function and the dictionary, if you want, where you keep all the previously computed values. And this instances of this class should have the same behavior as before. You don't want to modify the behavior to the outside. You just want to add the functionality, the trick to a function that it caches its previous computations. So in order to do this, you need to be able to simulate a function call. And this is done by making your cached object callable. So you have to define this method call on the cached object. Okay, there are many more use cases for magic methods, and this is reflection, where you look inside of the object, what it actually consists of, context managers, descriptors, copying objects, so deep copy, what does that do, and pickling, so saving objects to more permanent storage. In general, an excellent resource is in that link to a website that supplements the Python documentation. So if you have questions, I really encourage you to look there as well as asking me.